Have you ever looked up at the night sky and seen a bright star that wasn't a star at all but a planet? A world like our own, just over there. But how far is over there? We see pictures and diagrams all the time with planets neatly lined up looking like friendly neighbors on a cosmic street. But these diagrams are liars. They have to be. Otherwise, the page would need to be miles wide. The distances between planets aren't just big. They are mind-bendingly, soul-crushingly, almost unimaginably vast. What if I told you the planet closest to us on average isn't Venus or Mars? It's Mercury. That sounds wrong, doesn't it? How can the innermost planet be the closest neighbor to all the others, even Neptune? It's a paradox that shows how our intuition is warped by static images. The reality is a celestial ballet, a constant dance of orbits where close and far keep changing. The space between worlds is so immense that even light, the fastest thing in the universe, takes minutes, sometimes hours, to cross the void. When we send a command to a rover on Mars, we wait for our message to crawl across the solar system, then wait again for the reply. It's a conversation with a delay measured in millions of kilometers. So let's peel back the curtain on those misleading diagrams and look at the true, wild, wonderfully empty distances between the planets. First, let's throw away the idea of a static solar system. It's a myth. Every planet is in constant motion, hurtling through space at incredible speeds. Earth, for instance, is moving at about 30 kilometers per second. But they don't all move at the same speed, nor do they follow perfect circles. Their paths, their orbits are elliptical, slightly stretched out circles. Let's look at our most famous neighbor, Mars. The distance between Earth and Mars swings wildly, like a cosmic yo-yo. At their closest approach, an event called opposition, when Earth is directly between the Sun and Mars, the two planets can be as close as 54.6 million kilometers. I say close because that's still more than 140 times the distance from the Earth to the Moon. When Earth and Mars are on opposite sides of the Sun from each other, a configuration known as conjunction, the distance between them balloons to a staggering 401 million kilometers. That's more than 7 times the minimum distance. While Mercury might be our closest friend on average, Venus holds the record for the single closest approach to Earth. It is our true sister planet, not just in size and composition, but sometimes in proximity. When the orbital mechanics align just right, the gap between Earth and Venus can shrink to about 38 million kilometers. That's significantly closer than Mars's best approach of 54.6 million kilometers. But if you ask, which planet is, on average, closest to Earth? The answer is surprising. It's Mercury. Mercury, on the other hand, has a small, fast orbit. It never wanders too far away from the Sun, which means it also never wanders too far away from us. The same logic applies to every other planet. On average, Mercury is the closest planet to Venus, Mars, Jupiter, Saturn, Uranus, and Neptune. It's the closest neighbor to everyone. This massive difference is why space agencies like NASA have specific launch windows for Mars missions, typically occurring every 26 months. They have to wait for the planets to align in just the right way to make the journey as short and fuel efficient as possible. Missing that window means waiting another 2 years. The reason we focus so much on Mars is that its surface, while hostile, is far more manageable than the hellscape of Venus. But in terms of pure distance, Venus is the neighbor that can lean over the fence for the closest chat. This immense distance has a very practical consequence. Lag. Not internet lag, but the fundamental lag imposed by the speed of light. Light, and therefore any radio signal, travels at about 300,000 kilometers per second. While that seems instantaneous on Earth, it's sluggish on an interplanetary scale. Let's go back to Mars. When Mars is at its closest, a signal sent from Earth takes about 3 minutes to reach it. That's a 6-minute round trip for a conversation. Hello, Perseverance rover. How are you? 6 minutes of silence. I am fine, thank you. Now consider when Mars is on the opposite side of the Sun. That same signal now has to travel a much longer path. The one-way travel time stretches to about 22 minutes. That's a 44-minute round trip. Imagine trying to remotely drive a rover with that kind of delay. You'd push the joystick to turn left, and the rover wouldn't even receive the command for 22 minutes. This is why Mars rovers must be highly autonomous. They can't be driven in real time. They are given a set of commands for the day, and then execute them on their own, reporting back hours later. If the lag to Mars is significant, the delay to the gas giants is on another level. Let's look at Jupiter, the king of the planets. It's so big you could fit all the other planets inside it, but it is also very, very far away. Depending on where Earth and Jupiter are in their respective orbits, the one-way light time ranges from about 35 to 52 minutes. Think about that. When you look at Jupiter through a telescope, you are not seeing it as it is right now. You are seeing it as it was almost an hour ago. You're looking into the past. If Jupiter were to suddenly vanish, we wouldn't know about it for at least 35 minutes. A light minute is about 18 million kilometers. So, Jupiter is, at its closest, 35 of these massive units of distance away from us. The gap between us and that giant stormy world is not just empty space. It's a gulf of time that we have to cross with every single bit of information we send or receive. There's a reason we often talk about the inner and outer solar system. Between the orbit of Mars and the orbit of Jupiter lies a vast and mostly empty region known as the Great Divide. This is the home of the asteroid belt, a sparse collection of rocks and minor planets left from the solar system's formation. But the most striking thing is its sheer size. The gap between Mars at its farthest and Jupiter at its closest spans about 550 million kilometers, or roughly 3.7 astronomical units. Out in the far reaches of the solar system, the distances become even more profound. Let's just consider the two ice giants, Uranus and Neptune. They may look like neighbors in diagrams, but they are separated by an astonishing void. Depending on their orbital positions, the distance between Uranus and Neptune can range from about 11 AU to 21 AU. That's a minimum of 1.6 billion kilometers and a maximum of over 3.1 billion kilometers. To put that into a light speed perspective, a signal traveling between them would take anywhere from 90 minutes to over 175 minutes one way. That's nearly 3 hours for light to cross the gap between these two neighboring planets at their farthest. They are lonely giants, each tracing its slow, cold path around the sun, separated from its nearest sibling by a gulf of space and time. These colossal distances are reflected directly in the time it takes us to travel them. We can't travel at the speed of light. Our spacecraft are more like celestial snails. A typical mission from Earth to Mars takes about 6 to 9 months. The Voyager 2 spacecraft took 8.5 years to reach Uranus and a staggering 12 years to finally fly by Neptune. The travel times are a stark reminder that the planets are not destinations. They are remote islands in a cosmic sea. Finally, let's address a common image from science fiction: the perfect planetary alignment. It's a dramatic visual, but it's also a complete fantasy, because the planets do not all orbit on the exact same plane. Their orbits are all slightly tilted relative to one another. Even when grouped together in the sky, they form a crooked, jagged line. The solar system is, and always will be, beautifully messy. The familiar map of our solar system is a comforting lie. The planets are not cozy neighbors. They are wanderers, separated by voids of unimaginable scale. We are shouting across a cosmic ocean, and the faint echo we hear back is a testament to our ingenuity and our unyielding curiosity. The planets are far, but they are not unreachable. They are simply waiting. And every time we receive a new image from a distant world, we shrink that distance just a little bit. And as always, thanks for watching.